Students, welcome back to night classes. We are starting second chapter of geometry. It is Pythagoras theorem. As you know, we are studying all theorems at the end when there will be no any confusion of solving examples. So first examples using the properties. Before proving every theorem is a property. So to solve 2.1, exercise 2.1, which properties we need, we are going to see it. So first property is Pythagoras theorem. Theorem. What it says? It says hypotenuse side. This is hypotenuse side. Hypotenuse square is equal to base square, that is BC square, plus AB square. How to prove? It is not a question at present. The only remembering. Second is Pythagorean triplet. Pythagorean triplet means largest side square is equal to sum of other largest number, sum of other two numbers. Third is 30 degree, 60 degree and 90 degree property. Fourth is 45 degree, 90 degree property. And fifth is geometric mean. This one. There is four properties. We will see when we solve the examples. It's 2.1 is little bit revision, little bit new things are coming in the way. So we are solving them as per requirement. So let me explain you what is Pythagorean triplet. If 3, 4 and 5 these numbers are given, no units, only numbers are given, then 5 square is equal to 25 and remaining the largest number is 5 and the remaining are 3 square plus 4 square is equal to 9 plus 16 is equal to 25. Then these three numbers are called Pythagorean triplet. These three numbers are called Pythagorean triplet. If they are not following this condition, say 3, 7, 9. 9 square is 81. 7 square plus 3 square is equal to 49 plus 9 is equal to 58. So this is not a Pythagorean triplet. Means Pythagoras says if you use these numbers as units, say centimeter, meter, whatever it may be, you cannot draw a right angle triangle. You cannot draw a right angle triangle. If they are Pythagorean triplet, the triangle can be drawn. Otherwise, right angle triangle cannot be drawn by taking any numbers. So he gave the name Pythagorean triplet. Now third is 30, 60, 90 degree property. Suppose this is a right angle triangle having measurements 30 degrees, 60 degrees and 90 degrees. This sign shows it is a 90-degree angle. So, what this property says, if hypotenuse is of x units, hypotenuse has got length x unit, then side opposite to 30 is half into x. The length of side opposite to 30 degree is half of the hypotenuse, and side opposite to 60 degree is root 3 upon 2 into hypotenuse, length of hypotenuse. So this is called 30 degree, 60 degree, 90 degree property. So side opposite to 30 is half of the hypotenuse, and side opposite to 60 degrees is root 3 upon 2 into length of hypotenuse. This is called 30 degree, 60 degree, 90 degree property. Next is 45, 45, 90 degree. So suppose we are given a triangle where P, Q, R are the points. This is 90 degree. This angle is of 45 degree, 45 degree. In this case, if hypotenuse is of x units, then side opposite to 45 is 1 upon root 2 into hypotenuse, length of hypotenuse, and this also 1 upon root 2 into length of hypotenuse. Length of hypotenuse. These two properties are used to solve the examples in this exercise. Now the next property is geometric mean. Geometric mean. Suppose we have a triangle that is right angle triangle. Right angle triangle. And we draw a perpendicular from 90 degree angle to hypotenuse. If we draw a perpendicular from 90 degree angle to hypotenuse, suppose it is D. We have drawn a perpendicular to hypotenuse from 90 degree angle, correct? Perpendicular to hypotenuse. So condition is BD perpendicular to AC. BD perpendicular to AC. And first condition, triangle ABC. In triangle ABC, angle B is equal to 90 degrees. Angle B is equal to 90 degrees. So if these two conditions are there, triangle ABC is a right angle triangle and BD perpendicular to AC, then geometric mean says BD square is equal to AD into CD. AD into CD. We can check by taking other triangle. Suppose this is a right angle triangle. We have drawn a perpendicular P, Q, R and S. This must be perpendicular. So, triangle PQR, in triangle PQR, angle Q is equal to 90 degrees and QS perpendicular to the hypotenuse PR. Then we can write QS square is equal to PS into SR, yeah, RS, whatever it may be. Both meanings are same. So we have seen Pythagoras theorem. Second is Pythagorean triplet. Third is 30 degree, 60 degree, 90 degree property. Fourth is 45, 45, 90 degree property. And last is geometric mean. By using these, we are going to solve exercise 2.1. Let us see the examples. We are starting exercise 2.1 depending on the given 5 properties. First question is identify Pythagorean triplet. So question number 1 says the numbers are given 3, 5, 4. 3, 5 and 4. Just we have taken it, but we have to solve the exercise. So largest number is 5 here. 5 square is equal to 25. Statement 1. Next, 3 square plus 4 square is equal to 9 plus 16 is equal to again 25. So from 1 and 2, statement 1 and 2, we can see 5 square is equal to 3 square plus 4 square. Therefore, 3, 5, 4 are the Pythagorean triplet. Means by taking these 3 units or any measurement depending on these 3 numbers, you can draw a right angle triangle. So this is a Pythagorean triplet. The second one, is 4, 9 and 12. 4, 9 and 12. 4, 9 and 12. So here same 12 square is equal to 144 and remaining two smaller numbers 4 square plus 9 square is equal to 16 plus 81, which is equal to 97. 16 plus 81 is 97. Therefore, since 12 square is not equal to 4 square plus 9 square, therefore 4, 9 and 12 are not a Pythagorean triplet. So you can check with compass boxes, drawing instruments. If you take 4 centimeter, 9 centimeter and 12 centimeter, you will never able to draw a right angle triangle. So this is the statement made by Pythagoras. If there are certain triplets, then only you can draw the right angle triangle. Otherwise, it will not be possible to draw right angle triangle. This is the very simple thing. Remaining, I think you can do at home. It will make you practice of calculations. So this is second question. We have solved the Pythagorean triplets, and this is second question from exercise 2.1. It says triangle MNP, angle MNP is of 90 degrees. Correct? NQ is perpendicular to PM. MQ is 9 units and QP is 4 units. So they said find length of NQ. After seeing the figure, you can directly say this example is depending on the geometric mean property. Geometric mean property. The solution, nothing has to prove. We have to find the solution. Here, angle M and P is equal to 90 degrees. Correct? And NQ is perpendicular to PM. Given things. Therefore, these are the given things. Therefore, we can use the property of by geometric mean property. Geometric mean property. NQ square is equal to MQ into PQ or QP. Therefore, NQ square is equal to MQ is 9 and QP is 4. Therefore, NQ square is equal to 36. NQ square is equal to 36. So we have to take the square root. Take square root. Take square root. Therefore, NQ is equal to 6 units. This is the answer. This is the answer. Measurements are always positive. So square roots in geometry are always positive. Don't get confused with algebraic square roots. In algebra, plus square root may be plus, may be minus, but here it is always positive since the measurements are always positive. Keep it in mind. Clear? Now we are in the third question of exercise 2.1. In this figure, they have given angle QPR is of 90 degrees. Is of 90 degrees. First thing. Second thing, they have given PM is perpendicular to QR. PM is perpendicular to QR. We are not in hurry. We should go slow. Slow things will help you to grasp the things. Shouting, acting, impressing the things. It is not a job of teacher. So, spoon feeding, the first lecture I told you, Naxer's teaching is spoon feeding. Children should be given with spoon. Food should be given with spoon. Small pieces will help you to digest the food. Similarly, calm, quiet explanation will help you to understand geometry. People say geometry is a very difficult subject, but if you make friendship with geometry, it will give you full marks. Full marks. So calm and quiet, no haste, nothing gadbad. Come. So again they have given PM equal to 10 and QM equal to 8 and they have said find QR. Find QR. I told you just by seeing the figure you should recognize which property it is geometric mean. Solution. Angle QPR equal to 90 degrees and PM perpendicular to QR given. Correct? Therefore, by geometric mean property, PM square equal to QM into MR. So what is PM? PM is 10 is equal to QM 8 into MR. We are not knowing the measurement of MR. So therefore 100 is equal to 8 into MR. Therefore MR is equal to 100 upon 8, which is equal to 2 4s are 2 50s are 2 2s are 2 25s are. So 25 upon 2, which is equal to 12.5. They are not given any centimeter and unit, so you have to use units. No, they are not given any units. So units are units. Now they said find QR. QR is equal to QM plus MR. Segment addition property. In childhood we have studied this segment addition property. Therefore, QR is equal to, what is QM? 8 plus what is that MR? 12.5. So, QR is equal to 20.5 units. 20.5 units. This much simple examples are there. Use in not very great intelligence for this. Only simple calculations will give you the things very nicely and answer very nicely. Keep head cool while solving the geometry examples. So, question number 4. This is the figure they have given and they said find these two sides. So, let us see here. Angle ABC equals to 90 degrees. ABC equals to 90 degrees. And AB is equal to BC given. So when these two sides are same, by isosceles triangle theorem, when sides are same, angles are same. So this will be 45 degrees and 45 degrees. 45 plus 45, 90, 90 plus 90, 180. Sum of the angles of the triangle is 180. We have studied this. Therefore, angle A is equal to angle C is equal to 45 degrees. When we got the hint that the angles are 45, 45, the property is 45, 45, 90 by 45 degrees, 45 degrees and 90 degrees property. Side opposite to 45 degrees, AB is equal to half in 1 upon root 2 into hypotenuse is equal side hypotenuse side opposite to 45 degrees, and BC is equal to again root 1 upon root 2 into hypotenuse side opposite to 45 degrees, side opposite to 45 degrees. What I said, keep head cool, everything is easy. So you can write hypotenuse means AC. Therefore, AB is equal to 1 upon root 2 into root 8, which is equal to root 8 upon root 2. So it will be under root 8 upon 2, which is equal to under root 4, which is equal to 2. So have they said the second one? Now they are not, I am doing extra. now ABBC, they were done it in combination. Anyway, anyway, we are done separately. You can write here BC equal to AB equal to. Clear? Property is important. One is isosceles theorem, the other is by 45, 45, 90 degrees property. There is one correction. What example just we solved? It was example number 5, in which we used 45, 45, 45, 90 degree property. And now we are solving example number 4. So the previous example was example number 5. I have solved it first. I had written there example number 4. Please correct it. Please correct it. It doesn't matter. In this figure, here angle PSR is equal to 90 degrees given. Angle P is equal to 30 degrees. It is also given. Therefore, angle R is equal to 60 degrees. Since sum of angles of triangle is 180, one is of 90, one is of 30, so remaining angle is of 60. So it is called third angle of a right angle. Third angle of a right angle triangle. Correct? So this is 60 degrees. This is 60 degrees. What they have asked us to find, they have said find RP and PS. RP and PS. Very good. Therefore, by 30 degree, 60 degree and 90 degree property, we can say side opposite to 30 is half of the hypotenuse. Correct? So SR is equal to half into hypotenuse. Side opposite to 30 degrees. So it will be 6 is equal to half into hypotenuse is RP, SP. SPR. Yeah. Therefore, RP is equal to 6 to the 12 units. RP is equal to 12 units. And remaining side SP and SP is equal to root 3 upon 2 into hypotenuse side opposite to 60 degrees. So it will be SP is equal to root 3 upon 2 into hypotenuse. Just we got the hypotenuse 12. 2 ones are 2 6 are. It is 6 root 3 units. So the measurements RP is 12 units, hypotenuse RP is 12 unit and SP is 6 root 3 units. Once again I am repeating. I had taken fifth example first and written there 4. Please correct it. Okay? Yeah. This is sixth example of exercise 2.1. They said find the side and perimeter of a square whose diagonal is ABCD. We have taken square as a ABCD. ABCD. So what is given? Quadrilateral ABCD is a square. Quadrilateral ABCD is a square. Diagonal AC is 10 units. Find any side means all sides are equal. Side and perimeter of the square. Find side and perimeter of the square. Solution. Since here quadrilateral ABCD is a square given, correct? Therefore AB is equal to BC is equal to CD is equal to AD. Sides of a square. Suppose L8 is equal to X and angle B is equal to 90 degree. Properties of a square. All sides are equal and all angles are 90 degrees. So triangle ABC is a right angled triangle. Therefore angle B is equal to 90 degrees. Right angle triangle. Therefore by Pythagoras theorem, hypotenuse square is equal to that is AC square is equal to AB square plus BC square. But we have assumed AB equal to BC equal to CD equal to AD is X. So it will be AC square is equal to X square plus X square. AC square is equal to X square plus X square. But AC is 10 square. AC is 10, so AC square is 10 square. Therefore, 2x square is equal to 100. Therefore, x square is equal to 100 upon 2 is equal to 50. Therefore, x square is equal to under root 50. Therefore, x square is equal to under root 25 into 2. Therefore, x is equal to 5 root 2. Taking square root. Again I am explaining, ABCD is a square, so all sides are equal. Let them be x. Angle B is 90 degree. We can apply Pythagoras theorem. Applied, we got 10 square is equal to 2x square and 2x square is equal to 100. So 2x square, 2 went to that side, x square is equal to 50, x square is equal to under root 50, sorry, x is equal to under root 50. So x is equal to 25 into 2. So finally x is equal to 5 root 2. 5 root 2. Therefore, side of a square is equal to 5 root 2 units. And perimeter perimeter is equal to 4 into x is equal to 4 into 5 root 2 is equal to 20 root 2 units. 20 root 2 units. So this was sixth example of exercise 2.1. Exercise 2.1. This video we are ending here. The remaining examples will be in the next video. The remaining examples will be in the next video. 7th, 8th, 9th and 10th. Clear? We will see in the next video. Good day.